Good morning, Abby. It's about 9 a.m. on Wednesday morning, and I thought I would jump into the semester exam for first semester. This is our last thing for first semester. It's still open, so I thought I would help you with these problems. So here, I'm just going to go over the ones that you got wrong. So we have what percent of weight of Na2S2O3 is sodium, and then it gives us the weights for each one of those. So we know how to do this. We list everything out with its quantity. So Na, there's two of these. So that's going to be, it's going to equal 2 times the weight of Na, and the weight of Na is 23. So 2 times 23 is equal to 46. Then we have sodium, or wait, this is sodium, this is sulfur. Sorry. And there's two of those, and the weight of the sulfur is 32. I think it's sulfur. I don't know what it is. It's S. I'm calling it sulfur. 2 times 32 is going to be 64. And then we have oxygen. There's 3 of those. So oxygen is equal to 3 times, and the weight of oxygen is 16. It's a 3, by the way. And 3 times 16, that'll be 8, carry a 1, 48. The total weight, or grams, is going to be these added together. So this is going to be 10, this is 18, carry 1, that's 11, plus 4 is 15. So 158 grams is the total weight of this, whatever this is, whatever this recipe, I guess it's the right word, whatever it's making. So we need to find the percent of the sodium, the Na. So sodium, Na, is going to be 46 out of 158. And that's going to equal some percent. And a percent is written as x over 100, something over 100. That's the fraction that we use for percent, right? So we're just going to cross multiply. 46 times 100 is 4600. And then you get 158x. So we divide both sides by 158. And pull up my calculator here. 4600 divided by 158 is 29.11. So it says to round to the nearest whole percent. So the nearest whole percent is going to be 29, because this 0.1 is not enough to round this to 30. So 29% is our x. That's going to be your answer. You put 3%, and I think what you did was you rounded this up to 3. I'm not sure why you did that. 29% is what we're looking for here. Okay, the next one was number 6 that you needed help with. This one right here. So what you did was you solved it to a decimal. We do not want you to solve it to a decimal. Instead, we want you to solve it to a fractional exponent. So when we look at this, we have, I'm just going to redo it over here, the third root of 25 times the square root of 5. So what we're going to do is we're going to start by making the bases the same. So this is going to be, we know that 25 is 5 squared. Now that we have the bases the same, we can address that. We start with the innermost square root, and that's going to be 5. And it is written one time, has an exponent of 1, and then it has there's no number here, so that's a square root. So square root is a 2. Now we have 5 to the 2, right? And it is written once with an index of 3, so 3 is here. All right, so now we just multiply everything. So 1/3 times 2, that's going to be 5, and 2 over 3. then 1/3 times 1/2 is 5 and 1/6. We want to be able to combine our bases, so we're going to change this to where it is the same denominator. 5 and 4/6 times 5 and 1/6. We know when we have the same denominator, we can combine. So the answer is going to be 5 and 5/6. We're not solving for a decimal. We're solving the exponent. Okay? That's the point of that problem. All right, so let's look at the next one was number 7. So this one is just straight multiplication across. We don't have anything internal. So we just write m squared p7, and that is written one time under the radical with an index of 5. And that's going to be m times m5p, and that's written one time under the radical with an index of 3. So now we just multiply. So m 2/5, p 7/5, m 5/3, p 1/3. We need to have the same denominator, which is going to be 15, because 3 times 5 is 15. So I multiply this by 3/3, m 6/15, p 21/15, m, this is going to be multiplied by 5/5, so 25/15, and p 5/15. Now we can combine the like bases. So 6 plus 25, this will be 31. So m 31/15. P is 21 plus 5, so it's 26/15. And that would be your final answer right there. Okay? It's not about the base. It's not about actually solving for an answer. It's about understanding how fractional exponents work. That's what we're going for. All right, number 10 is the next one that you did struggle on. So this one. So let's see. Let me roll this up out of the way. So we have r squared c over m cubed minus c squared. All of that is over 4/m cubed minus r/m cubed. Well, the good news here, they both have the same denominator, so I can actually rewrite this as one fraction. 4 minus r/m cubed, because they have the same denominator. I want to do the same thing up here. So I'm going to multiply this and turn this into a fraction and multiply this by m cubed over m cubed so that I can turn this into the same one. So when I do that, I get r squared c minus c squared m cubed over m cubed, all divided by 4 minus r over m cubed. Well, this is a fraction divided by a fraction. So you could rewrite that with the division symbol like that, right? So when you can do it like that, we know we can keep it, change it, flip it. So technically this is going to be c r squared, if we write it in alphabetical order, minus c squared m cubed over m cubed times m cubed over 4 minus r. So the m cubes cancel. So this is actually going to be cr squared minus c squared m cubed over 4 minus r. That's your final answer. And don't worry about typing these in. Do them in alphabetical order. I'm not sure how they're in the system. I didn't look at that. But I will look at the answer, and if it's just in the wrong order, I'll mark it right. All right, if it's not in the same order, I won't say wrong order. If it's not in the same order as the answer key, but it's the correct exponents and whatnot, I will mark it correct, okay? Don't stress too much about that. All right, next one was number 11. Okay. So we are wanting to complete the square here. So negative 7x is equal to 5 minus x squared. So we need to have them all on the same side, or we need to have the x terms all on the same side. So I'm going to add x squared to both sides. So that gives me x squared minus 7x. We leave a little space, and that's equal to 5. So I'm going to take the middle term, negative 7, and divide it by 2. I can't really get a clean number, so we leave it as a fraction. And then I square that, and that's going to equal 49 over 4. This is the number that we add to both sides. Okay, so my next step is to make this to where I can combine it. And when I do that, I'm also going to factor this. I don't even have to think about it because it's right here for me. So this would just be x minus 7 over 2 squared. And that's going to be equal to 20 over 4 plus 49 over 4. All right, so when I unsquare this, I'm going to get x minus 7 over 2 is equal to the square root of 20 plus 49 is 69 over 4. All right, so I am going to unsquare that. So that's going to be plus or minus the square root of 69 over 2, because 4, the square root of 4, is 2. So we solve that one, and now we're just doing the square root up here. And 69 is going to be the same as 3 times 13. We can't reduce that any. That's as far as we can go with that. I'm sorry, 3 times 23, not 13. But 3 times 23 is 69. 23 is a prime number. 3 is a prime number. We can't do that, anything else with that, so it is what it is. So now we just have to get x by itself. So we are going to add 7 over 2 to both sides. So x is equal to 7 over 2 plus or minus the square root of 69 over 2. And this is your solution. Okay. Next term, or the next problem that you need help with was number 13. Let's look at that. My hand is tingly. I need to get some circulation. I've been holding the mouse too long. Sorry. Okay. All right, so we're going to write this out right quick. X squared minus 3x minus 6. Make sure that's big enough for me to see that. Minus 3 equals x minus 2. All right, so I need to get the radical by itself. So I'm going to add 3 to both sides. When I do that, I get the square root of x squared minus 3x minus 6 is equal to x plus 1, because the negative 2 and the positive 3 make a positive 1. All right, so I'm going to square both sides. When I do that, I get x squared minus 3x minus 6 is equal to x plus 1 times x plus 1, because we squared both sides. When we squared this side, the radical went away. When I square this side, I have to write it twice and multiply. So let's do that part. X squared minus 3x minus 6 is equal to x times x is x squared. Then we have x times 1, so it's plus 1x. And then 1 times x, that's another 1x, so it's going to be 2x. And then 1 times 1 is 1. All right, so that's what we get when we distribute. So now I'm going to combine these to one side. So let's subtract x squared from both sides. Okay, the x squares go away. And I'm going to subtract 2x from this side. So that goes away. And I'm going to add 6 to both sides. So this goes away. So I have negative 5x is equal to 7. So x is equal to a negative 7 over 5. And the way I got that was I divided both sides by negative 5. And the denominator is never negative, so we move it to the top. All right. So x is equal to negative 7 over 5. That is our solution. All right. I think the rest of these to the end you needed help with. So let's look at the next one. All right. Find the equation of the line that passes through 2 and negative 7 and is parallel to the line that passes through negative 4, 4, and negative 6, 6. Okay, so it looks to me like y is going to be equal to this first line is going to be equal to a negative x. I'm pretty confident in that. So let's look at finding the slope of the line. So the first thing I need to do is find the line, equation of the line for these 2 points. So that's going to be 4 and negative 4 minus 6 minus negative 6. These are the y's and these are the x's. This is one point, this is the other point. All right, and that's going to equal negative 2, and negative 4 plus 6 is going to be a positive 2. So that is going to equal a negative 1. That's our slope. So y is equal to negative x plus b. So I'm going to take this first point because it's smaller. The y is 4. We have a negative 4 is the x plus b. So 4 is equal to 4 plus b. Subtract 4 from both sides. And I have 0 is equal to b. So my equation of the line is y is equal to negative x, which is what I thought it was. Because if you look, y is equal to the opposite of x. Y is equal to the opposite of x. That's literally what we're doing. Okay, so that means my slope here is a negative 1. So I'm going to use the same formula to find this line, and I'm just going to sub in this point. So y is equal to negative x plus b. Y is negative 7, and then that's going to be a negative 2 plus b. Add 2 to both sides. Negative 5 is the value of b. So in this line, I have y is equal to negative x minus 5, because that's the value of the b, and that's what we substituted in here. So that's going to be what you type in. You would just type in negative x minus 5 should be correct. Oh, it doesn't check it for you because it's a test. That's why. Well, I knew I hadn't been checking it. I was like, why didn't I check it? It's because it's a test. All right, it's not going to tell you if it's right or wrong. Anyway. All right, find a to the hundredths place. In order to find a, I have to find one of these degrees of measure so that I can then find Pythagorean's theorem. And I'm going to need to find z because I have a degree here, or a measurement here, right? So if this is 135, I'm going to actually just take this and copy it over here so that I can write on it, because that will help me more than anything, and it will help you more than anything to see me write on the structure. All right, so here's that. So if this is 135, all right, 135, and let me use the red pen so you can see it. This is a straight line. So these two together have to equal 180. So 180 minus 135 is the value of x. So that's going to be, let me rewrite this for you so you can see it better. 135 plus x is equal to 180. These two together equal 180. So I'm going to subtract 135 from both, which is the same thing I did. I just jumped ahead a little bit. This helps you visualize that better. X is going to be equal to 45. So x is 45 degrees, okay? 45. If x is 45, these are corresponding angles. So they are going to be congruent. So this is also 45 degrees, which means if this is 90, and it is, that this is also 45 degrees. So what that tells me is we have a similar triangle here. I could use similar triangles to solve this. So my similar triangle, oh, actually, dang it, I can't use a similar triangle yet because we haven't done those, I don't think. Let me check my table of contents and see where you learn about that. Yeah, we haven't gotten to that one yet, so I can't use that. So I have to use Pythagoras' theorem or SOHCAHTOA. I think y'all have learned SOHCAHTOA. Yeah, I'm pretty sure y'all have used. Yes, that was lesson 43, sine, cosine, and tangent, which is SOHCAHTOA. Sine, cosine, tangent, SOHCAHTOA. And these are the formulas for those. So we know sine is the opposite over the hypotenuse. And then the cosine is adjacent over the hypotenuse. So we could use either one because they're the same degree of measure. Doesn't matter. I'm going to use sine because 45 is the opposite is 8. So I'm going to say the sine of 45 degrees is equal to the opposite, which is the one it's looking at, of 8 over the hypotenuse, which is a. So I multiply both sides by a. I get a times the sine of 45 degrees is equal to 8. I'm going to divide both sides by the sine of 45 degrees. So I get that a is equal to 8 over the sine of 45 degrees. So now I'm going to pull out my calculator and I'm going to find the sine of 45 degrees. So 45 sine, all right, is 0.707107. And that is what I'm going to clear this. So that's what I'm going to use to divide 8 by. So I'm going to put it in my calculator like this. 8 divided by, parenthesis, 45 sine, parenthesis, equals 11.313. So I'm going to round this to the hundredths place because it tells me. So 11.31. A is equal to 11.31. All right. That's it. That's all I have to do. So we're done with that problem. Next problem. Convert 400 square kilometers to square miles. So 400 kilometers, it's square, so kilometers again, over 1 to square miles. So I've got to go with from kilometers to meters, so times 1,000 meters. And you could do it in one fraction. It works. 1 kilometer, 1 kilometer, 1,000 meters. I know you've never seen me do this before, but it's the same thing. It just makes it so I don't have to write another fraction. Now I'm going to go, this cancels this one, and this cancels this one. This is not so much a different technique, it's just a different style of writing the same technique. Okay, so now we're going to go from meters to centimeters. So 100 centimeters, 100 centimeters over 1 meter times 1 meter. Cancels, meters. Now we're going to go from centimeters to inches. So 1 inch times 1 inch, 2.54 centimeters, 2.54 centimeters. Centimeters is canceled. All right, inches to feet. So 1 foot is 12 inches. Now we're going to go from feet to miles. So 1 mile is the same as 5,280 feet. 1 mile, same as 5,280 feet. All right, we're done. We have miles times miles, that's miles squared. So now we just have to go back and look at what all we did. So we have 400 times 1,000 twice times 100 twice. And the rest of the stuff in the numerator is the factor of 1. 1, 1, 1, 1. All right, 1, 1, 1, 1, 1, 1. So we can drop those. In the denominator, we have 2.54 twice. And we have 12 twice. And we have 5,280 twice. You see that here at the end. And our unit of measure is miles twice. So miles twice. That should be your answer. Just like that. Okay? Alrighty. I hope that helps you see that a little bit better. And it says to use exponents in your answer, so it wants you to do the exponents here, not write this twice, but use the exponent. So that's what it's asking you to do. All right, number 17. We're going to find x. Oop, it's right there. I couldn't resist, sorry. M over c minus 3a plus e over x equals f. All right, common denominators. We see x. We're multiplying by everything that particular term doesn't have as a denominator. So cx, this has the c, so we need to multiply by x over x times m over c. This doesn't have either as a denominator, so we need to do cx over cx times 3a over 1 plus. This one has the x, so we just need to multiply by the c times e over x. And this one doesn't have either. So we'll multiply by both times f over 1. Okay. We know that in doing this, now everything has the same denominator. So all we need to do is multiply the numerators. We can drop the denominator. So that's going to be mx minus 3acx plus ce is equal to cfx if we write everything in alphabetical order. All right, so now we have everything that we need to solve for x. So I have x over here, so I'm going to add 3acx to this side as well. And I'm going to subtract mx because it's the other x term. All right, so now this cancels, CE is equal to CFX plus 3ACX minus MX. If I factor out the X, I get CF plus 3AC minus M. If I divide both sides by the second factor, X is going to be equal to CE divided by CF plus 3AC minus M. All right, that's going to be my solution. This is what you would type in. Next problem. We only have a few more to go. It's not so bad. All right, we're going to convert 864 to rectangular form. So first you have to figure out where it lives. And this is going to live in that first quadrant. because it's between 0 and 90 degrees. So this is 0, this is 90. 64 degrees is going to live about right here. 64 degrees. And then we create this, the length here, 8, that's the hypotenuse. That's the length of the hypotenuse. So we're going to drop down an imaginary line, and we're going to figure out the legs of the triangle. And that's your rectangular form. So this is going to the positive side of the x-axis. It's a positive r. Towards the positive side of the y-axis, so it's a positive u. So all we have to do is multiply the hypotenuse times the cosine of the angle to find the r term, and the hypotenuse times the sine of the angle to find the u term. So we just pull out our calculator. So let's see, we've got 64 cosine times 8. We round that to 2 places because that's what we do. This actually will bump this up to 1. So 3.51 r is the first term. And 64 sine times 8, 7.19 is the second term. This is the length of r. This is the length of u. We just add them together. 3.15 r plus 7.19 u is your rectangular form. And that's it. Very little math. It's all about understanding where it's located to determine whether it's positive or negative. All right, the next problem is 19. All right, so I'm going to copy this image over. It just helps me because I like to draw on the image. It helps me solve it better. Make it big enough to see. There we go. All right, so we are finding x in terms of a, b, and y. All right, so we have to figure out what is corresponding to one another. So we know that vertical angles correspond. So these two are going to correspond. And we're told these two are the same angle. So that means then that these are going to be the same angle as well. Now I can look at how to read these, right? So I've got the red to the green angle is going to be the same as the red to the green angle. So let's call this triangle A, triangle B. All right, from the red to the green on A, red to green on A is A. Red to green on B is X. Okay. Then I've got from the red to the blue, red to the blue. Red to the blue on A is B. Red to the blue on B is Y. Okay. And there's nothing given for the other one, green to blue, green to blue. We don't really care about that. So this is our proportion. This is how they relate to one another. So we can solve this for x. So what I'm going to do is I'm going to multiply. I need to get this. Actually, no, we can just cross multiply. So we got ay is equal to bx, right? If I divide both sides by b, I get x by itself. So x is equal to ay over b. Easy peasy. That was not too hard. You just have to figure out how you want to think about it. And it really helps when you use color or some identifying factor so that you can keep the sides that correspond. You know, you can see which sides correspond. It makes it easier, right? So I used color instead of the degree of measure to help me understand which is which. All right, so that is 19. Last one. Yay! And of course it had to be one like this. So let's copy the image over and paste it. And we'll enlarge it so we can see what we're looking at. All right, here we go. Put this up here like this. All right, so we want to find, I don't know why it's doing that. There we go. We need to find M, N, P, and Q. Okay, so we know that when we have a arc of a circle right here, let me get a different color. This is an arc right here, and it's intercepted on the circle. When we have a inscribed angle, that's one that goes all the way to the other side, it's always going to be half of what the arc is. So N is going to be equal to 46 divided by 2, which is going to be 23 degrees. So N is 23 degrees. So if this is 23 degrees, we know the inside of a triangle always equals 180. Let's call this X just to keep up with it, right? So that means that 23 plus 26 plus X is equal to 180. So 23 and 26, that's going to be 49 plus X is equal to 180. So if I subtract 49 from both sides, X is going to be equal to 131. All right, so this is 131. All right, so we know that N is 23. All right, so N is equal to 23. M is equal to, let me scroll this down just a bit. If X is 131, we know that these are congruent because they're opposite angles. So M is equal to 131 also, right? Right. Now, the other thing we know is that this point and this point are shared by this angle here. So this angle is going to be the same degree of measure as N. N is going to equal Q, so Q is equal to 23 degrees also. And if that is true, if this is 23 degrees, and we know that this is 131 and this is 131, then this has to be 26 as well. Then these two have to be the same as well. So P is equal to 26 and Q is equal to 23. And those are your results. 131, 23, 26, and 23 in order. All right, so just a little bit of logic. You only really had to know that these two circumscribed angles would be half of 46. And therefore, these two are going to be the same degree of measure. These two are the same degree of measure, which would then make these two the same degree of measure because of the nature of a triangle. All right, that's all for the algebra semester exam for the first semester. If you have any more questions, please feel free to ask.